Hey everyone, Morgan here. So we're still talking about titration. We're on page 12 of the Ionic Solutions lecture. And this is really background information. You're not going to see a question like this on an AP exam. You might see a question like one specific part of this, but not an overall process like this whole page. But it's still something that's really helpful to do because it helps to point out to you how pH changes during a titration. And that's kind of why I had set this as for something for you to do on your own. So we'll start with a strong acid, strong base titration. And it's going to be the titration of 100 milliliters of 0.1 molar HCl. That's the analyte. And we are titrating with 0.1 molar NaOH. Calculate the pH before we have added any of the NaOH. Oh, well, that's straightforward. It's a strong acid, so the H plus is just 0.10 molar. So the pH equals the negative log of 0.10, which equals 1.00. There you go. That's it. Now, once we get to adding some of the NaOH, the reaction is H plus OH minus makes H2O. It's a 1-to-1 ratio. So how much H plus am I starting with? Well, it's 0.10 molar times 100 milliliters, and that's going to equal 10.0 millimoles of H plus. Now the hydroxide, when I've added 15 milliliters, the hydroxide was also 0.10 molar times 15.0 milliliters, which equals 1.5 millimoles. And that will be completely consumed. So 10 minus 1.5 millimoles, the amount of H plus that's left over now, is 8.5 millimoles divided by 100 plus 15, which is 115 milliliters. And the milli cancels out. Millimole is kind of a cool little unit, pun completely intended there, that allows you to not have to do lots of conversions back and forth between liters and milliliters. The milli just cancels out, and we get 0.0739 molar. So the pH is the negative log of 0.0739, which equals 1.13. So now let's try and understand something. I started with acid. Its pH was 1. I added a little bit of base, and the pH went up to 1.13. Yeah, that actually makes perfect sense. That should be happening. Okay, what about after I've added a total of 35 milliliters? Well, the H plus is still originally 10.0 millimoles. Calculated that up here. Okay. Now my OH minus is 0.10 molar times 35.0 milliliters, 0.1. That's 3.5 millimoles. 10 minus 3.5 is going to give me 6.5 millimoles. Okay, so I've got 6.5 millimoles. And my total volume is the 100 milliliters plus 35, or 135.0 milliliters. Milli cancels milli. And this ends up equaling 0.0481 molar. Okay, so that's the H plus, pH. We take the negative log of that number, and I get 1.31. Okay, this is still continuing to make sense. The pH is going up as I add base. Now, 50 milliliters. H plus to start was 10.0 millimoles. And I think I can recognize now that the OH minus is going to be 5.0 millimoles. Which leaves me with 5.0 millimoles of H plus divided by 50 plus 100 is 150 milliliters. Okay, that is 0.0333, etc., molar. I take the negative log of that, and I get a pH of 1.48. Okay, now a lot of base has been added, 99 milliliters. 10.0 millimoles of the H plus to start with, minus 99 times 0.1 is 9.9 millimoles, which means the amount of H plus that I have left over is 0.10 millimoles of H plus divided by 199 milliliters, which equals 0.0005 molar. When I take the negative log of that, the pH equals 3.30. So it has jumped up quite a bit. It's gone from 1 to 3.3. And remember, pH is a logarithmic scale. So each change of a full point of pH, like from 1 to 2, is a factor of 10 change. All right. The equivalence point. Well, the pH equals 7. The pH is 7 for every strong acid, strong base titration. But let's look at why. 10.0 millimoles of the H plus minus 10.0 millimoles of the OH minus, 0. I have no leftover H plus, I have no leftover OH minus. The pH is 7. Okay. Now what if I overshoot a little bit? Well, what I'm going to do now is I'm going to do the hydroxide first, which is going to be 10.1 millimoles minus the 10.0 millimoles of H plus that I started with, which is 0.10 millimoles of hydroxide that I've got left. I'm going to divide that by 201 milliliters. That's an excess reactant now. This equals, hey, 0.0005 molar hydroxide. So the pOH is equal to 3.30 this time, or the pH is 10.7. And you know, this really makes a lot of sense. I start off with just acid. It has a pH of 1. Add some base, it goes up. Add some more base, even more. Add a lot of base. And then when I have an equal amount of acid and base, I get a pH of 7 because it's a strong acid and it's a strong base. But then as soon as I go past the equivalence point, that pH needs to shoot up quite a bit because now it's just straight hydroxide ion that is actually determining the pH of what's in that solution. Okay, that's page 12. We'll do a slightly different example on the next page involving a species that is weak. Thanks for tuning in. This is Morgan, signing off.